Hello, hello, hello. Hope everybody's having a great and wonderful snow days. Um, anyways, so we left class knowing sample proportions, and here's our opportunity to again practice sampling proportion. The expectations are that when we get to class, you would have watched sampling means, and then we would work on sampling means in class rather than sampling proportion. Unfortunately, the AP Stat exam moves for nobody. So that's why we have to do this work because, we keep losing days. So it's really important that we get in all the material before the AP Stat exam because I want you guys to be fully prepared to take on this exam. Anyways, sampling proportion practice problem. So I'll give you a problem. You can then pause the video, write down the question, and then answer it. And then and then you should unpause the video, and then I will go over that problem. And I will do this 5 times. There are only 5 practice problems. Honestly, sampling proportion, they're not too bad as long as you remember the checking the two conditions, and then just it's more about how you answer the question than what the answer actually is. Because obviously you can easily find the answers on a calculator. Um, so it's really important that we go over how you answer these. Anyways, on to problem 1. The Gallup poll asked a random sample of 1,785 adults whether they attended church during the past week. Let the proportion of people in the sample who attended church. Um, a newspaper report claims that 40% of all U.S. adults went to church last week. Suppose this claim is true. What does it mean of sampling distribution of um, no, there should be a P right there. Y. Find the standard deviation of the sampling distribution. Check to see if the 10% condition is met. Is the sampling distribution of whatever approximately normal? Check to see if the large count conditions are met. And of the poll respondents, 44% said they did attend church last week. Find the probability of obtaining a sample of 1,785 adults in which 44% or more say they attended church last week if the newspaper report's claim is true. Does this poll give convincing evidence against the claim? Explain. So pause the video, answer these questions as best as you can, then we'll go over problem 1. The mean is 0.4, and we know this because the sampling proportion is an unbiased estimator. So that means the mean of the population is going to be equal to the mean of the sampling distribution of the sample. And remember, our formula for standard deviation is the square root of the proportion times 1 minus proportion all over the sample size. And that gave us a standard deviation of 0.016. And also the large count condition, the 10% condition, the 10% condition does in fact work because I'm pretty sure there are more than um, 17,850 adults. Large counts, 0.4 times 1,785 is greater than 10, and 0.6 times 1,785 is also greater than 10. Okay, so you guys don't have your inspires, but as long as you draw the little chart, you'll be fine. As long as you draw that curve right there on the very right, that's all you really need to do to show your work on the AP Stat exam. All that calculator talk on the left side, the lower bound, upper bound, mean, standard deviation, will not give you credit on the AP Stat exam. So it's really important that you at least show the curve on the very right. So anyways, if you had an Inspire, your lower bound would be 0.44, your upper bound would be 100, your mean would be equal to 0.4, your standard deviation would be 0.0116. And so we got um, a probability of 0.000282 or a 0.02% chance. So there is a 0.02% chance that an SRS of 1,785 adults who went to church last week will have a proportion greater than 0.44. B is more of like a, well, you tell me. It's a very qualitative answer. There's not really sort of a wrong or right answer as long as you understand that, hey, 0.02% chance is very unlikely. So excuse me, problem two. A US Today poll asks a random sample of 1,012 US adults what they do with the milk in the bowl after they eaten the cereal. Let the proportion of the people in the sample who drink the cereal, let, yeah, again, I don't know why I'm missing all the variables. I don't think they copied into this PowerPoint, right? A spokesman, spokesperson, we don't want to be gender discriminant, for the dairy industry claims that 70% of all US adults drink the cereal milk. Suppose this claim is true. Yada yada, A, B, C, and D are pretty much the same questions from problem one, so I'm not going to read those out again. That would take way too much time. So we know the sampling proportion is 0.8 because, well, the population proportion is 0.8, and because it's an unbiased estimator, we know that the proportion of the sampling distribution is also going to be 0.8. 1,012 times 10 is greater than 10% of the population of cereal eaters. So that means we can do the standard deviation. Standard deviation is equal to the square root of 0.2 times 0.8, all divided by 1,012, and that is equal to 0.013. Large counts also checks out. Boom. Problem 2. Lower bound, really big negative number. Upper bound, 0.67. Again, we're looking for the probability of less than 0.67. So that's why the lower bound is negative 100. The mean is 0.70 and the standard deviation is 0.013. And so yada yada yada, put in your calculator, your hypothetical calculator, and there is a 1% chance of an SRS of 1,012 milk drinkers that will have a sampling proportion less than 0.67. So that means if I did this a billion times, there's only 1% of all the sampling distributions that I, randomly asked 1,012 milk drinkers, will have less than 67% of them drinking milk. I think that's, yeah, yep. Pretty simple, pretty cut and dry. And honestly, like, this is all you'll be doing for each of one of these problems. Pretty cut and dry. Problem 3. A mail order company advertises that it ships 90% of its orders within 3 working days. You select an SRS of 100 of the 5,000 orders received in the past week for an audit. The audit reveals that 86 of these orders were shipped on time. A. If the company really ships 90% of its orders on time, what is the probability that your proportion in an SRS of 100 orders is 86 or less? Show your work. A critic says, aha, you claim 90%, but in your sample, the on-time percentage is lower than that. So the 90% claim is wrong. Explain why your probability calculation shows that the result of the sample does not refute the 90% claim. Again, before we answer this problem, we have to check our 2 conditions. Remember our 2 conditions, 10% condition, 100 times 10 is greater than 500, 5,000. And the large counts, 0.9 times 100 is greater than less than 10, and even though it's 0.1 times 100 is equal to 10, it just needs to be greater than or equal to 10. The mean is 0.90, and the standard, and oh yeah, so the 2 conditions check out, so we know we have a normal distribution. Mean equals 0.90, again, because it is the unbiased estimator, and standard deviation, again, is square root of 0.9 times 0.1, all divided by 100. Plug that into your calculator, and so you have a probability of 0.09. Remember, you are looking for less than 86. So there's a 9% probability that an SRS of 100 orders will have a sampling proportion of less than 0.86. And because there's a 90% chance of this happening, while it is not likely to happen, there's still a possibility of it happening. Problem 4. The Harvard College Alcohol Study finds that 67% of college students support efforts to crack down on underage drinking. Does this result hold at a large local college? To find out, college admins survey an SRS of 100 students and find that 62 support a crackdown on underage drinking. Whew! Suppose that the proportion of all students attending this college who support a crackdown is 67%, the same as the national proportion. What is the probability that your proportion in SRS of 100 students is 0.62 or less? Show your work. Again, check your conditions. 100 times 10 is obviously, that should be less than 10% of the population of college students. The large counts check out again, and our mean is 0.67, and our standard deviation is 0.047. Plug that into your calculator. Because you're looking for less than 0.62, your lower bound is going to be the really big number, mean, standard deviation, and so we get a 0.41437. And so there's a 14% chance that an SRS of 100 students has the same proportion less than 0.62. Pretty cut and dry. This is really how you would do each one of these sampling proportion problems. Problem 5. What sample size would be required to reduce the standard deviation of the sampling distribution to 1/2 the value you found in problem 4? Pretty tricky, but it's actually not that bad. It's honestly a little bit of algebra. This is probably the most algebra you'll do in this class. So we know back our formulas for standard deviation was square root of 0.67 times 0.33, all divided by 100, and that gave us 0.47. So from there, well, how do we know what sample size will give us half of that sample size? Well, why don't we just divide 0.047 to get 0.0235? Set our sample size to x and then just solve for it. So it'd just be 0.0235 squared and then divided by 0.67 times 0.33, and you solve for x and you get 400. So that's pretty interesting. So remember that fact. In order to cut standard deviation in half, you have to increase your sample size by 4 times. Pretty crazy. And that's all we have. So try these problems. Hopefully you understood it. Call me if you need me. Call me, beat me if you want to reach me. And watch the sampling means videos. Great, cool. See ya. Richard out. Oh crap. Whatever. Mr. Cho out. Whatever. Anyways, bye.